Yeah. So guys, give the headline. Aromatic hydrocarbons. We'll talk about benzene. Aromatic hydrocarbon. So guys, aromatic means, what is aromatic? We have already discussed this in GOC. Students who are attending online, am I visible? Can you all see what I have written on the board? Please confirm.
Yes, sir.
All right. So guys, see here in aromatic hydrocarbon means as per Huckel's rule, right? Or you can say according to Huckel's rule. What does it suggest? Who can be aromatic? Where few conditions should match. First, it is supposed to be a cyclic. Second, apart from cyclic, each carbon should be a planar. What do you mean by planar? Planar means sp2 hybridization should be there. Each carbon of the ring should have sp2 hybridization. Okay. Third condition it should satisfy, that is there should be a conjugation. There should be a conjugation. Conjugation should be there in the entire ring. When resonance, conjugation means resonance. When there is a resonance in the entire ring, then only it is considered as. So these are the three requirements. Fourth one is very important. That is the pi electrons, the pi electron should be the number like 2, 4, you know, not 4, my bad, 2, 6, 10, 14, 18, 22, and so on. So if this is your value of the pi electron, then only if it satisfies all those four conditions, then only you can say the compound is aromatic. Okay, online, is everyone clear about this condition? Kindly confirm, dear students.
Yes, sir.
All right. Now, I'll tell you one more thing. One more thing, guys. If you see, I will draw a benzene ring here. Now, tell me one thing. Is it cyclic? Is it cyclic? Avantika, can you tell me, is it cyclic? Yes. Tanvi, this is a
Yes,
cyclic
sir.
structure, right?
Yes, sir.
Now, tell me, is each carbon is sp2? How do we know it's sp2? There should be 3 sigma bond. Let's find out. If you check any one carbon, you will see it has 1 sigma here, and there must be one hydrogen, right? So there is 1 sigma. You can check for any carbon, they all are sp2. So 3 sigma bond means, dear students, 3 sigma bond means sp2. So it is planar. So two conditions are satisfied. Do you see a resonance here? See, the entire ring has a resonance. Pi, sigma, pi, sigma, pi, sigma, pi. Remember, in resonance, we have seen 4 patterns. Pi sigma plus, pi sigma minus, pi sigma pi, and pi sigma free radical. So see, the entire ring is conjugation is there. Pi sigma pi, pi sigma pi, pi sigma pi. So three conditions are satisfied. Tell me how many pi electrons are there? How many pi electrons are there? Who can tell? Shreya? Ritvik, can you tell me? How many pi electrons are there? Ananya?
So 3 pi electrons.
Yes. 3 pi, no.
6.
Yes, very good. So there is 6 pi electron. One, 2, 3, 4, 5, 6. 6 pi electrons are there. So does it match with the number? Yes. So hence this compound is aromatic. Take a note of it. Okay. So how are we getting these numbers, guys? So these numbers are coming in from a formula that is 4n. All of you write down the formula that is 4n plus 2 pi electron. How these numbers are coming? Where n can be any integer, say 0, 1, 2, 3, 4, and so on. So when n is 0, what will be 4 into 0? 0. So what is it? 2. When n is 1, 4 into 1 plus 2, 6. And so on it goes. I hope it's clear to everyone. Ritvik, you got it now? Tanvi,
Yes, sir.
Pranav. Alright guys. Now let's learn the since you have learned this, it's the conditions for aromatic, right? Now let's learn the preparation of benzene. So all of you write it down. And guys, also remember in aromatic compounds, I'll tell you one additional thing. In aromatic compound Avantika, you can see that this is the conditions you have got, right? These are the conditions needed to be aromatic, okay? Hello?
Got it, sir.
Okay. So guys, remember one more thing. What you need to remember here is in aromatic compound also, remember aromatic compounds are the most stable compounds. Please write it down. Aromatic compounds, aromatic compounds are highly stable. Write it down a point for aromatic compounds are highly stable. They are stable than any other compounds. Okay, they are highly stable because they have a very powerful resonance. Okay. Now, guys, remember in aromatic compound, who is the most stable? So remember the number 675. This is your number 675. It means the six-membered ring is the most stable one. Then comes 7 and then comes 5. Please write it down. 675. This is the number which is generally we see is stable. So among aromatic also six-membered ring will be the most stable, then 7, then 5. Okay, 6 is the most stable. Guys, please write it down. Now let's do one thing. Let's do one thing here. Let me give you one few questions, okay? Where let's see you are able to identify the given compound is aromatic or not. Okay? So guys, are you all ready? And yeah, please be careful. I'm giving you a J question, so you have to solve properly. Okay? You will identify whether the given compound is aromatic or not. Identify, identify, identify the aromatic compounds. Let's see how we'll get it. Identify the aromatic compounds. So guys, I'll give you the first option. You have to just tell me yes or no and the reason. So your first question is, guys, comment on this. Is it aromatic or not?
Yes, sir, it's aromatic.
Okay, Ritvik, why it is aromatic? Is it cyclic?
So it has 2 pi electrons, sir.
First of all, it is cyclic, yes. Do you see that? See, cyclic is there. Planar to by default you consider. Okay, it will be planar. Now, after planar, can you check? Is there a resonance? Guys, tell me, do we see a resonance here?
Yes, sir.
There is a resonance because which resonance is there? Pi sigma plus. So pi will change here to the plus. So what is the result we'll get? So our result will be that the pi electron will shift here and plus will come here, right? Because this carbon is in loss. Yes or no? Now, do we have a resonance again? Yes. One more time, pi sigma plus, so it will shift here, right? So what do we get now? So what do we get? So now what will happen? The pi shifts here and the plus shifts here. So see, the entire ring is in conjugation. So it can, remember, conjugation is there, it's not the perfect confirmation. Ritvik, understand that. If one resonance happens, doesn't mean that it is going to be aromatic. The condition is entire ring should have a conjugation. It means when you draw the hybrid, it means when you draw the hybrid, this was the ring, so the dotted line should come everywhere. Is everyone clear what I'm trying to tell? Avantika, you understood, right? The double bond
Yes,
needs to be present everywhere. Then only we consider the conjugation is complete. If it's incomplete, then we will say it's not aromatic. Got it? Got my point? Avantika, you are clear, no?
yes, sir.
Yeah. And finally, how do we write the hybrid? Partial positive was here, it was here, and it was there. Done. So it
So can you
satisfies.
explain again why it's not aromatic?
Yeah, Ritvik, I'm glad you asked that. I was wondering that some student might have a doubt that if one time resonance happens, that's also is considered, or the entire ring. Remember, the entire ring should have a conjugation. Ritvik, you can see that the partial double bond character is present in the entire ring. Can you see that?
Yes, sir.
Ritvik, yeah. So when partial double bond is present in entire ring, then only we consider the conjugation point. Okay. Then only you can tick mark that the conjugation checkbox. Is it clear? Is it clear? Okay.
Yes, sir.
Shreya is also not in the class. Guys, take a note of this.
So the number of pi electrons here, like
Yes, so count the number
usually,
of pi electron. Pi electron, you don't, you can see there is only two pi electron. For pi electron, you can consider any one of the resonating structure. You just see one of the resonating structure, that is your pi electron. So how many pi electron are there? Just consider any one of them. Avantika, understand, at a time there is only two. Can you see that?
yes,
So
sir.
hence it is two. At a time it is 2, so hence the pi electron is 2. So if your pi electron is 2, does it match with our condition? Yes. Is it clear for everyone? Pranav Iyer,
So usually when there's minus, they consider that also as a pi electron, right?
Avantika, ask your question again. Can you tell?
Usually there's if there's a minus, they also consider that as a pi electron, right? So
No, 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 no. I'll tell you. Only those lone pair, minus means a lone pair, right? So only those minus or only those lone pairs are considered as a pi electron if they are involved in resonance. Avantika, you understood my point?
yes, sir.
If they are involved in resonance. If they are not involved, then they are not considered. Okay, glad you
So
asked this
the
question.
plus does not affect the number of pi
No,
electrons,
no,
right?
no, no. Plus has no relation with the, pi. Plus is just used in the conjugation. Okay,
So,
okay.
sir, here they are not involved in resonance, right?
No, plus cannot be involved, right? Only the pi electron is involved, right? You got it, no? Plus is not
So,
even
sir, it's
considered as a lone.
aromatic or
Understand, Ritvik?
Yes,
Plus
sir.
means loss, not the gain. Plus is a loss.
I know that, sir. So
Huh.
in the end, like this compound is aromatic or non-aromatic?
In the end, it is aromatic because it has two pi electron. Can you check? There's only two pi electron, no, at a
Oh
time.
yeah, yeah, okay, sir.
Is it clear for everyone? All right. Now I'll give you another question. Guys, please comment on this. Okay, let me see how do you get this. My question is this ring, there's a double bond and there's a plus. Guys, comment on this. Please comment on this.
So it's aromatic, right?
I don't know. You have to tell me. You have to tell me. Only Ritvik has answered. Ananya,
Oh
online
wait, I
Pranav.
Sir,
don't
I
think
think
so,
it's
sir, because
aromatic.
it's
Okay, Tanvi and Avantika. What is your answer, guys?
sir,
Sir, it is
one thing I
aromatic.
think it follows cyclic, but I don't think it's sp2, so maybe it's not aromatic.
Ritvik, for SP2, you don't have to worry. In the given question, all of them will be SP2. That you take my guarantee. You don't have to check for SP2. SP2 by default it will be there. Check for other conditions. SP2 you don't need to check. That is something you should be least bothered. Just for the namesake, rule sake, I have given you that as it should be SP2. See, by default all are SP2. Okay, so SP2 you don't need to check. Ritvik, all are SP2. See here, this carbon has how many bonds? Tell me. One, two. Ritvik, you are getting my point?
Yes, sir.
Yeah, so SP2 you consider it by default. You don't need to check SP2. Check about other conditions. Tell me now, do you see a conjugation is there? Pi sigma plus, right? So what will happen? This will shift there, right? Pi will change the plus. So what is the new structure you'll get? So bi bond will come here and where will be the plus charge? The loss will be here. Now tell me, do we have a conjugation again? Pi sigma plus. If I do this, isn't it we are going in the same direction reverse? That means the resonance is not there in the entire ring. That means it is not having a resonance. No resonance. Conjugation is not complete, okay? So it has a incomplete conjugation. What it has? It has incomplete conjugation. Tanvi, you got it? Avantika, Ananya? Ananya, please see. There is incomplete conjugation. It's not happening in the entire ring. The double bond are only coming in this position. See, the double bond is only here and here. That's all. These two positions are missing. There is no double bond. There is no double bond. Right. So resonance is not complete. Ananya, did you understood this?
Yes, sir.
So hence the answer will be it is neither aromatic nor anti-aromatic. The answer it is non-aromatic. The answer is write it down. The answer is non-aromatic.
So
They
the
are.
plus sign comes back to the same position, that's why it's
That
incomplete
is why we
conjugation, right?
again you will see if I shift it here, isn't it? The pi electron will come here and plus will come there, right? So you'll get the same structure. You
Yes.
can't go back. You can't go back in reverse direction, right? You have to go clockwise in one direction. Ritvik, you are clear?
Yes, sir.
Okay. Anyways, we'll take more examples. It'll get more clarity. Okay.
So anti is 046 of 8, 048.
Yeah. How do you check for a leap year, which is divisible by 4? So for anti-aromatic also, if it's the number is divisible by 4, then it will be anti-aromatic. Okay, Vantika? Hello.
Yes, sir.
Hmm. See, it can't have a zero number. Avantika, zero nahi ho sakta. It can't be zero because if it is zero, it means there is no pi electron. And our anti-aromatic and aromatic is based on resonance. And for resonance, we need pi. So zero is cannot be okay. It has to be divisible by 4. Then it is anti-aromatic. Avantika, you're clear, right?
Yes, sir.
Yeah. Okay. So guys, let's do a third one. Anyways, right now, don't check for anti-aromatic. I'm just giving you between aromatic or non-aromatic. Anti-aromatic, we'll talk about it later. Right now, I just want you to purely focus on aromatic, okay? To understand the aromaticity, okay? Aromatic compounds. Now, so guys, please comment on this, what this could be. I'll give you a substance. Hmm, I got one very, very good one. My dear students, tell me what is this? Please check carefully and then only you tell. He's coming. All right. Guys, please tell me the answer, what it is. Hmm. Avantika, Tanvi, anyone?
Aromatic.
Aromatic. Are you sure it's aromatic? See, there is a resonance, no doubt. But how many pi electrons are there? See, this also is involved in resonance. Do you see the pattern? My dear students, do you see the pattern here? What is the pattern? There is a pi sigma lone pair, right? So when you see this pattern, what happens? The lone pair comes down, huh? The lone pair will come here and the pi will shift here. And then again the entire resonance will start, right? So how many pi electrons are there? How many pi electrons do we have here? Tell me. How many pi electrons are there?
Exactly 8.
8 pi electrons. 8 or 6? 6, 8, 8, 6. Tell me, comment on this.
6 pi electrons plus the lone pair, right?
See, I'll tell you. When you draw the resonating structure, Avantika, so what is the first? I'll just show you one, okay? There are 5 resonating structures. I'll just show you one. So what will happen? There will be a double bond on the carbon and oxygen because lone pair came here. This oxygen is bonded to hydrogen and it still has a lone pair. And because it has donated, so there will be a plus charge, correct? And what will happen next? Next, what will happen is there will be a minus, correct? And then what will happen? There will be a pi electron, correct? Pi bond. So it seems like it has 8 because I have told no lone pair which participate in the resonance is also considered as a pi bond. So it looks like 2, 4, 6, 8. So 8 means it becomes anti-aromatic. When it's a multiple of 4, it becomes anti-aromatic. Anti-aromatic are just opposite of aromatic substance. Aromatic compounds are the most stable. Anti-aromatic compounds are the most unstable one. They are so much unstable they don't exist. They are hypothetical. In reality, they don't exist. Ritvik, you're getting my point what I'm saying? Ananya,
Yes, sir.
Yes, sir.
Pranav and Tanvi. Okay, so guys, understand it looks like based on the point I said that if the lone pair is participating in a resonance, it is also considered as a pi electron. So in that way, it looks like 2, 4, 6, 8. And if it is a multiple of 4, it means it's anti-aromatic. But reality is it's aromatic. It's a very stable compound. It's called phenol. Is it clear? How? Because I have told you draw the resonance and see at a time how many pi electrons are there. So this lone pair was not participating, right? See that carefully what I'm talking about. This lone pair was not participating, so we will not count that. At a time, how many are there? 2, 4, 6. Guys, getting it now in the ring. It is out of the ring. In the ring. Is it clear? So at a time you have just and just 6 pi electron. So hence the answer is aromatic. It only has 6 pi electrons. Avantika, did you get this? So answer is
Yes, sir.
it is aromatic. Ritvik, Tanvi, can you all confirm? Did you all understood this?
Yes, sir.
Yes, sir.
Okay. Ananya, you're clear, no?
Yes, sir.
Okay. Now, next question, next challenge, guys. Please find out what is this one. So you have this. It's like a pentagon. I will draw a pentagon. There will be a double bond, and I'll put plus. Now tell me what is this? Comment on it, guys.
Non-aromatic.
Yes, it is very, very simple to answer. There is no conjugation only. There is no conjugation, right? It's very far. See, pi is here, sigma is here. Plus is supposed to be here, but it's there, very far, very far, very far. So no conjugation, okay? There is no conjugation. So write the reason, no conjugation, hence. So when there is no conjugation, it can't be either aromatic or anti-aromatic. So answer is so whatever is not aromatic or anti-aromatic, everything else is a non-aromatic. So answer is it is non-aromatic
So how is no conjugation?
because Ritvik it's see for conjugation what is the pattern we need pi sigma plus, right? Correct, Ritvik,
Yes, sir.
and this sequence you need in continuous. See there is a pi, there is a sigma, but where is the plus? It's very far. It plus supposed to be here or here, right? But it's there, it's far. You understood now, Ritvik? Ritvik, can you confirm? Did you understood, right?
Yes, sir. Yes.
Ha, that is why.
Yes,
Okay.
sir. I understand.
All right, guys. So let's do the next one. Next one, what we have is again a pentagon, and I'll put a negative charge here, a lone pair. Guys, solve this. Negative charge means there is a lone pair. Yep. Guys, tell me what is the answer. So answer is
So it'll be aromatic.
pi sigma lone pair. Okay. Pi sigma lone pair. Pi sigma pi. Very good resonance is there. Very good. There is a very good resonance. Now tell me how many pi electrons are there? Anyone? Guys, tell me. It has a very good resonance. Can you all tell me how many pi electrons are there? 4 or 6? Guys, there is 4 or 6. Most of the student answer it as 4. See, what they do is they'll just see this. They say 4 and they say it's an anti-aromatic. But you people know if a lone pair is participating in a resonance, it is also considered as pi electron. So the reality is how much? 6 pi electrons. So hence the answer is aromatic. Those who have not studied properly will say anti-aromatic. Okay. Ritvik, you got it now?
Yes, sir.
Okay. Ananya, Pranav, Tanvi.
Yes, sir.
All right, good.
Yes, sir.
Yes, sir.
Perfect. So now let's do another question. I think you people are getting a very good experience now. Please do remember it. Okay. So next one, guys, you have, I'll put 2 plus charge. Now tell me what it will be.
Non-aromatic.
It is non-aromatic. Are you sure? Avantika, I'm very curious. Why you said non-aromatic? You tell me. Wait, wait, wait.
Sure, no.
Yes, Avantika, are you changing your answer?
Yeah, 1 minute, sir. I'll.
Okay. Yes. Very good, Pranav. Ananya, tell me what is this?
So is it aromatic?
Yes, very good. Because see the conjugation pi sigma plus. So this will shift here. So what will happen? The pi electron will come here, plus will come here. Correct? Again, see pi sigma plus. So again it will shift here. And then, so entire ring is in conjugation, right? So the entire ring will be in conjugation. Very good. So when the entire ring is in conjugation, how many pi electrons are there? Just two. Only two pi electrons. Avantika, I think you got it now.
Yes, sir.
So answer is aromatic. Okay. So let's do a few more, one or two more. Should give you something with difficulty. Huh. Guys, tell me what do you have to say about this? Just do it carefully and tell. Yes. Guys, what is this answer?
Non-aromatic. No
Yes.
no
So
conjugation.
there is no conjugation, so straight away answer is non-aromatic. Very good. Anyways, now let's do some difficult ones. Okay. So guys, we will do some difficult one. So can you guys comment on this?
Aromatic.
It's aromatic.
Aromatic. How? Aromatic. Are you sure it's aromatic or anti-aromatic? Is it 6 or 8?
Sir, it's anti-aromatic. It's 8.
It's a tricky one. So Ritvik, you are saying it's anti-aromatic because 8 is there, right? Correct? Ananya, Vantika, give your final answers. Pranav, Tanvi, you also tell. What is your final answer? 6 or 8? 6 or 8? 6 or 8? Huh? Why 6? 1, 2, 3, 6 plus 2, 8. 8. Okay. So Ritvik and offline Pranav has an answer. It's anti-aromatic because it's 8 in the multiple of 4, right? Okay. Now Avantika, give your final answer. I like the confusion.
Celtic anti-aromatic.
Okay, Avantika is also with 8 electrons. Tanvi, what is your answer?
So even I'll go for anti-aromatic.
Very good, Tanvi. Now, Ananya,
Sir, anti.
you people are my best students because you people exactly do what I want. Okay, I want you all to fall in a trap and you all do the same thing. Answer is aromatic. Why aromatic? Because you will see this lone pair was never needed for resonance. We can do resonance without this lone pair. So this lone pair is never needed. See, you use a lone pair when it's required. No, it's not required. Without that, only resonance can happen. So that is why we will not count this. It's not participating in a resonance. So the answer is 6 pi electrons. I told you it's a trap question. So the answer is aromatic. Avantika, you clear?
So does pi sigma pi, right?
Yes, you
So, but
never
isn't
need
like
a lone
pi
pair.
sigma lone pair more in priority? Like that comes first, right?
No, nothing like that. Without that only we can do. And also even if you use a lone pair, what I'm telling is more three is enough because they are in sequence, right? So you don't really need the fourth one, okay? Is it clear?
Yes, sir.
Yeah. So see, remember, you bring the lone pair when it's required. You don't bring it unless needed. So that is why the answer is aromatic. It's one of the very stable compound. It's called pyrrole. Write the name also. You will need it in grade 12. Guys, write it down the name. Sorry, pyridine. My bad. So guys, write it down the name. Pyridine. What's the name of this compound? Pyridine. Remember, it works as a base. How does it works? Okay, now let me tell you more thing. Do you know what is a Lewis base? What is Lewis acid and Lewis base? Lewis base, lone pair donor, acceptor. You're getting it, no? So it is a lone pair donor because its lone pair is not busy in resonance. If its lone pair are busy in resonance, it can't be a donor and then it can't be a base. It is a base because its lone pair is free. It's not busy in resonance. I hope it's clear. So in grade 12, you will see some of the chemical reaction we use this as a base. Got it? No? So if you remember the name now and the structure, it will help you in 12th, which is about to start in the month of March. Okay? So guys, write it down. Okay. So are you all ready for another trap question? Okay. So guys, let's do another question now. So I'll give you one more question. Now I know you all are very much alert, but still let's give it a try. You all are alert now, and if I make you fall in the trap, I'll be way more than happy because this time you all are alert. Let's see what is your answer. See this compound carefully, then only give me the answer. Guys, see this compound. Take your time, then give me the answer. Guys, solve the I and J. Solve these two questions. Guys, is it done? Can you confirm? Everyone? Nobody is giving the answer now. Avantika, Ananya, what is the answer, guys? Tanvi?
Second one is aromatic.
Leave second one. Tell me the first one, the above one. See, this is very simple. There is 10 pi electron, right? There is a 10 pi electron. So what is the answer? So it fits in your formula 4n plus 2, right? So it is aromatic. There is no problem. This is 10 pi electron. It's aromatic. You know, if the number is 2, 6, 10, etc., etc., right? And actually, do you know in the formula, guys, pay attention here. Something interesting is there. 4n plus 2, right? Correct? 4n plus 2. Do you know what is the n in the formula? N can be 0, 1, 2, 3, right? Like that. So what basically is n? No, here n will be 2 because n is the number of rings. So when you put the value of 2 here, so what is 4 into 2 plus 2? So 8 plus 2, 10. So n indicates the number of rings. Is that clear? Got it, everyone? Yeah. So tell me the answer here. Nobody is taking a risk now. Tell, don't be scared.
Aromatic.
Okay. And Ananya, Ritvik, Tan,
Aromatic.
Aromatic, sir.
good. This time it is aromatic. Okay. So guys, that is why don't get too excited when you see a question. You have to do it as per the law and rule. And you have to keep your mind very, calm when you are solving the questions, especially during the entrance. Because whatever you have done for the last 2 years will be tested in that 3 hours. That is going to be deciding your future. So that is why a rigorous practice and most important, your kinetic energy needs to be low. You can't be electrons, who can easily get excitation. Is it clear? It's very, very important. Okay. So yes, the answer is aromatic. How many pi electrons are there? Six. Now we need this. It is required. So that is why it's aromatic. Very good. It's aromatic, 6 pi electrons. See, when lone pair is needed for resonance, you should take it. If it's not needed, then it's not required. Okay. And then we will not count it. Okay. So guys, now one last question. Just a second. So guys, write it down. This compound is called thiophene. Thiophene. Again, it will be needed in grade 12. It's called thiophene. Okay. So guys, next question now. Oh, so IJK. So in this compound, guys, now what I'll do, and yeah, do you know what this compound is? This compound is naphthalene. Write down the name. This compound, this J compound is called naphthalene. It's naphthalene, okay? Now I'll draw one more. Yes. So this compound, you have to find out what it is. So guys, what is the N here? How much will be the N now?
3.
3. So what is 4 into 3 plus 2? 14 pi electrons, right? 14 pi electrons. So 14 means which pattern does it follows? Aromatic, right? Check, confirm this. Is it 14? Yes or no? 1, 2, 3, 4, 5, 6, 7. 7 into 2? Yes. So it is, answer is aromatic. This also is aromatic. It's very, very simple. It's aromatic compound. Write down the name, what it is called. It's called anthracene. What do we call it? This is anthracene. JK. Now we will draw L. Last question, guys. Dear students, tell me what is this? See, how will you comment on this? Be careful, be careful. These two rings are not continuous. You know, these rings are connected. These two are not continuous, connected and continuous. So how will you do in this case? How many pi electrons are there? 6 plus 6, 12. So 12 is divisible by 4. So it is aromatic, but it's a trap. It's not anti-aromatic. Sorry, 12 means anti-aromatic, right? But guys, understand what happens. In such case, when rings are not continuous, we check the aromaticity of each ring. Separate, separate. You got it now? So write down the rule. Each ring should be aromatic. In such cases, each ring, each ring should be aromatic. Okay, then only we say it's aromatic. So 6 pi electron, 6 pi electron. So both rings are aromatic. Okay, so hence the overall answer is aromatic. So each ring has 6 pi electrons. Avantika, you understood this? Tanvi? In such cases, individual rings we will check. Okay,
Yes.
and this compound is called diphenyl or biphenyl. This compound is called biphenyl. Write down the name also. All right. Now, one question I will like to give you as a homework that you will find out and tell me. Guys, one last question now. Are you all ready? Last question, you will take it as a homework. Wait, more than I draw, I'll directly put a picture. It will be more easier, okay? It will be a waste of time. So guys, let me draw this, share this picture with you. It will be easier for me. Guys, let me show you the question. Just give me a second. Yeah. Yes, I have already shared, but let me show you also here. Can everyone see it? Guys, please confirm. Online, can everyone see it?
Yes, sir.
So, guys, this is the question. You have to comment. Will it be aromatic, non-aromatic, or anti-aromatic? Remember, I'll tell you for aromatic, there should be a complete conjugation in the ring. For anti-aromatic also, there should be a complete conjugation in the ring. The difference is if the pi electron is in the formula of 4n plus 2, where n can be 0 to any number, means like 2, 6, 10, 14, 18, 22, then it's aromatic. But if you are having a pi electron in the number as 4, 8, 12, multiple of 4, then it will be anti-aromatic. And compounds who are neither aromatic nor anti-aromatic, it means if there is no conjugation in the entire ring, it will be non-aromatic. Stability order, the most stable is aromatic, then non-aromatic, and the most unstable is anti-aromatic. Okay. So most stable is aromatic, then non-aromatic. The least is anti-aromatic. Okay. Remember, the conjugation should be present in the entire ring, then only we can consider it for aromatic or anti-aromatic, depending on what pi electron they have. And if lone pair is required in the resonance, then it will be considered as pi electrons. That is the overall summary. I hope it's clear to everyone. Ananya, you got it now?
Yes, sir.
Okay. So anyways, I have shared already the image on the group and on the Skype. Make sure that you solve and come back with the answer on the Wednesday's class. Remember, Wednesday we are going to do a revision on mole concept. Friday we will start the revision of chemical bonding. Okay. I hope it's clear. So guys, let's learn the preparation method. So all of you go give the headline. Everyone give the headline. Preparation of benzene. Guys, write on the headline. Preparation of benzene. Okay. So write it down. First method is the first method is cyclic polymerization. What was this first method, guys? Cyclic polymerization, where we have seen we will take three molecules of alkyne, right? Correct? And we'll pass it over red hot copper tube, right? Red hot iron tube or copper tube, whatever. You can use copper also, iron also. The temperature will be somewhere around 873 Kelvin. So what will happen, guys? This pi electron will break and will join with form a sigma bond with the carbon, right? So these three alkynes, they will join with each other, right? Like this. Guys, please see this. You all can see that each hydrogens are indicated here. Each carbon, will join here. Let me write it. I'll indicate the hydrogens. This is first ethyne. This is the second one. And then this is the third one. You can see that. So guys, here pi electron will form. Are you getting it? Correct. So each acetylene has two carbons. So there are three acetylene. That means there will be six carbon, right? So just multiply the numbers. 3 into C2, C6, and 3 into H2, H6. So it forms C6H6. C6H6, it means it forms a benzene ring. It will form a proper benzene ring. with alternate double bond where every carbon has a hydrogen. You can see that. It's a nothing else but a benzene ring. Guys, got it now? Is everyone clear? Cyclic polymerization. Okay. Remember, in each case, is 1 pi electron breaks and it results in the formation of sigma bond between the next carbons. Okay.
So
Avantika,
does
you're clear?
the pi electron or triple bond like bond between carbon carbon? Does it like transfer like that?
Ah, that's what. So it forms a sigma bond, right? You got it now? See, there is a sigma also, na? You can see that, right? Is it clear? That
Yes, sir.
sigma came from where? When the pi of each carbon broke. Understood now? Guys, please
Yes,
confirm
sir.
it once. So, guys, I'm curious now. Why I'm curious? I'm curious to give you one question now based on this. So it's time for questions, guys. Let's solve one question. Very important question. I'm curious to give you one question. So let's solve this question now. First of all, did you all copy this? Everyone copied this? Online, please confirm. Okay. So guys, the question is, what if in place of three acetylene, three ethyne, what if I give you three of these? Guys, please see this. What if I give you this substance? What is this? Tell me one, two, three. It's prop 1-ine, propine, right? So what if in place of ethyne I gave you propine? Now how will you do? Tell me. Again the same reaction. You pass the red hot iron tube. Red hot Fe tube. Obviously at the same temperature. Now tell me what do you get? Solve this question now, guys. It's very easy actually if you see. Crack this question. What do we get? Get the structure. Okay, how many people are getting it? Please tell me one is getting it. Guys, should I solve? If I solve it, trust me, it will look very easy. You just have to try it like this. Here it was ethyne and here it you have propine. Should I solve? Yes. See this CS3, I'll write it here. Wait, I'll use a different color. So this C, so one of the CS3 and then what you have? C and then what you have guys? Triple bond C and that has H. Yes. Similarly, the same substance, one I will place it here. Wait, I can't rotate it, so let it be. Wait. So write down one more substance here now. So another one, the CH3 will be here, which is connected with this C. Am I right? See, just like the above case, how I have written, right? Similarly, you write it. So one I have written, the other one you write like this. CH3, and that is connected with another carbon, right? Which has a H. Yes? Similarly, the third one you write, which has a CH3 here, right? And there's a carbon, carbon, triple bonded carbon. Just see, I'm writing it like this. One will be H and one will be CH3. Now what will happen, guys, among these three compounds? One will break to form a sigma bond. Tell me yes or no. Guys, tell me, are you all getting it?
Yes, sir.
Same thing will happen, right? So isn't it, it will also form a ring. Am I right? It will also form a ring with alternate double bond positions. Tell me yes or no. With CH3 groups present in place of H. Right? How many CH3s are there? One, two, three. So there is going to be three CH3s. Guys, write it down, all of you. So what do we get? So one CH3 will be here, another is here, and another is here. Every alternate positions you will have a CH3. That's all. Got it? Avantika, you understood this? Hello?
Yes.
All right. And guys, please understand this compound is has a name. It's called mesitylene. Write down the name of this compound. It's called mesitylene. Got it? No? Now, so guys, this was the first method, first preparation method, cyclic polymerization. Okay. Write down the second method now. Second method is decarboxylation. Second method is decarboxylation of aromatic acids. Decarboxylation means removal of CO2. Is it clear? So first we will take a carboxylic acid. You know that method, right? First we'll take benzoic acid. Yes or no? Then we will react it with NaOH. So guys, what happens when acid base reacts? Salt and water. So what will happen now? We will remove the hydrogen from here, plus minus, correct? So what is the answer we will get? We will get a salt of sodium salt of the acid, right? So C double O and A plus this OH and H forms H2O. Once we obtain the salt, what are we going to do, guys? We will put NaOH and CaO, right? Soda lime process, right? You know, chemical method of decarboxylation, right? That's what we are doing. So in this, once we have this C double O Na, we will add NaOH and CaO. We will add NaOH in the presence of CaO. This is called soda lime process. Is it clear, guys? And we will heat it. So now what is going to happen, guys? Carefully see this. We will remove Na2CO3. So CO2 is removed in the form of Na2CO3. So we will remove Na2CO3, and what are we left with? C and H. So guys, what did we got? Tell me, what did we get? Hmm? When you remove this Na2CO3, what are you left up with?
So H2O, right?
Benzene.
Yeah, understand, it will be Na2CO3 is left. Correct? Got it, no? Yes. So write it down. Only benzene will be formed, okay? Na2CO3 will be removed and it forms a benzene, okay? So remember the CO2 is removed in the form of carbonate. CO2 is removed in the form of carbonate. Please write it down. So Na2CO3 you can write it in the byproduct. Is it clear? Guys got it now? Yes. Yeah. Take a note, everyone.
Sir, what happens to the CH?
Yeah, I'll tell you. This CH also will be removed, okay? This bond will break, okay? This CH also is going to be removed. Okay, only benzene will be left. Is it clear?
Yes, sir.
Yep. Okay, one question. So guys, remember this. You are heating it, so Na2CO3 along with the H2O will be formed. Is it clear now? Just a second. I think I have circled it a bit wrong. Guys, let me rectify this. I've not circled it properly. So this was COONA, right? Right? And here it was NaOH. Correct? So how are you removing Na2CO3? I think I circled it wrong. So circling was wrong. That is why it created a confusion. So it's CO3, right? You're getting my point. Na2, these two Na and CO3. So this whole thing needs to be removed, right? Yeah, now it looks fine. Tanvi, you're clear now?
Yes, sir.
Now it's better. Okay. So you can write it here. CO2 is removed in the form of CO2 is removed in the form of Na2CO3. Okay, this is the statement. They might ask you where how decarboxylation is happening, where CO2 is removed. So you'll show that it is removed in the form, and this hydrogen will come here. This hydrogen will come here. Simple. It forms benzene. It will cover up for the loss of this COONA group. Okay. Online, everyone clear? Hmm. Last, last method, guys. Write it down. Write down the last preparation method, reduction of phenol. This is the very easy method. Reduction of phenol, guys. So what we will do, first we'll take a phenol. Okay. So this is our phenol. Okay. In the phenol, what we do, we add zinc dust. What do we add, guys? Now what this zinc will do, it will steal that oxygen. Is everyone clear? In the phenol, guys, what zinc will do, it will take up the, see, it removes this Zn will take up the oxygen. So it removes the ZNO. As a result, the hydrogen will shift here. Got it? So zinc oxide is removed and you are left with benzene. Very easy. I hope it's clear. Ananya, you understood, right?
Yes, sir.
Ritvik, Pranav, Tanvi, Avantika, please confirm once.
Yes, sir.
Yes, sir.
Yes,
Yes.
Yes, sir.
So, guys, that's all for today. Please note that chemical properties, it's a very small. We will cover up in the next class, and also in the next class, we are starting with a revision of mole concept. All right. So the next class is on Wednesday. Okay, at the same time. Okay. So 6 p.m. we will meet again on Wednesday, 6 p.m. to 7:30. Okay. Bye everyone. Yeah. Bye
Thank
guys.
you,
Thank
sir.
you, sir.
Thank you.
Thank you.